this is super fun. I've never presented in a stadium before. Thanks for joining me, and we'll try to keep this like kind of brief and fun. I realize that I am between you, like me and beer. Like there's beer back there in a little bit, and so and y'all looking forward to that. I'm looking forward to that. So let's dive right in. So I want to get to know you all a little bit. I'm a product manager for Kotlin at Google, and so I get to help thousands of Google engineers be successful with Kotlin and do the same with you all. But that's me. I want to get to know you, so I have a way for us to, for you to tell me about yourself. And so I don't know if you've ever used this, but you can trust my QR code, I promise. Or you can like go to slido.com and enter the code there. But this will be a fun way for us to get to know each other. I started using this just a couple weeks ago because I was doing a conference presenting in Stockholm. And I would ask the audience, do you have any questions? Do you have any questions? Do you have any questions? And no one ever asked any questions. And I was like, I expected some time built in for answering questions. And so I was getting a little frustrated. And I said, all right, if you don't start asking questions, I'm going to start showing Scala code. And so that got them to start answering some questions. So, okay, so here is the first poll, which let's go to the first question here, which I need to hit start on. What is your favorite thing about Kotlin? So that you can answer with, I think, up to 50 characters or something. I don't know if that's enough. Money. The money is awesome. Extension functions, null safety, coroutines. It's not Java. I've been doing Java for a long time, so I understand that sentiment. Runs on the JVM. It's fun. Yeah. Vars. Ooh, we can talk about that one later. I love vowels, which is another one on there. Null safety seems to be, that's strong. I love not getting null pointer exceptions in production. That's one of my favorite things. Great. Okay. Keep your Slido open. I'm going to come back to this a few times so that I can continue to get to know you. But I want to talk about my favorite thing. So my favorite thing about Scala, there's so many good things. We saw a lot of those up on the screen. My favorite thing about Kotlin is... Wait, is this a Scala talk? You're not asking enough questions? We got to talk about Scala? I'm going to talk about Scala a little bit, but my favorite thing about Kotlin is actually you all. Like coming from the Scala community, I have found the Kotlin community to be so warm and welcoming and kind and fun, and I appreciate that a lot. I appreciate that someone coming in who doesn't know anything about the language is just met with kindness, and I think that that's a really wonderful thing in a community, and hopefully we can keep that up and make Kotlin a place that's known for being kind and being fun. I think those are two things that really stick out to me about Kotlin. Obviously, a lot to love in the language and the tools. I don't think anybody said Gradle. Anybody say Gradle is their favorite thing about Kotlin? No, not my favorite thing about Kotlin either. But wait, that wasn't kind. I need to be kind to Gradle. So okay, let's make the Kotlin community, as it already is, a place that is kind and fun, and that's my favorite thing. But that's like my favorite thing, like overall. What I want to talk about in this talk is my favorite things for like this year, like things that hopefully we'll be able to use now, like right away. But before I go into my top 5, I actually want to hear, what are your top 5? And then we can compare and see if our top 5s are the same. So top 5 for this year, like things you're excited about in Kotlin this year, right now. Ktor, beer, yeah, I'm with you on that. KMM, context receivers, Quarkus, yeah, lots of good stuff. Compose, cool. Yeah, just using it. Yep, I'm excited to use it more. K2, I'll talk about some of that stuff in a little bit. Lots of good answers. Thank you. Okay, so we'll do more of this. So stay in Slido. What didn't make the list on my list this year is context receivers and WASM support. Both of those I am very excited about. I'm just not sure if I'll be able to really use them this year. So absolutely, I think there's a lot of good stuff coming. Number of great things that are on the horizon for Kotlin. But I didn't include context receivers and WASM, even though I am excited about them, just because I don't know if they're going to be kind of ready for my use this year. So my first thing that I'm excited about in Kotlin this year is what is happening around the inner dev loop for server-side developers. And so the way that I work is I try to keep my iterations when I'm working on something to be as tight as possible. I have like this inner developer loop, which I'm sure is similar for a lot of you, where I see red squigglies in my IDE, and that's my first indication that something is not right. And that hopefully is an experience that is, very short. We're talking hundreds of milliseconds to like get that feedback that something is wrong in the IDE. But then at some point, I actually want to like take my code that I have compiled and actually like run it in some way. And that could be running, rebooting my server. That could be rerunning my tests. That could be rerunning my Android application, which we'll talk about in a little bit. But I want to keep that iteration loop as tight as I possibly can, because I'm not a good programmer. And so I have to do a lot of iterations to get to where I want to go. And so keeping that developer loop as tight as possible is really important for me. And so I want to actually try a demo. I'm going to try to do a bunch of demos today. But the first one, I'm going to use Quarkus, which is a server-side framework that supports Kotlin. And I'm going to go over to their Gradle build and just run the Quarkus dev task here. And what this does is this starts up a server. But it's a server that is watching my sources for changes and will automatically reload my application and does a bunch of other cool stuff too. So just like the auto reload piece, like you can do that in Spring Boot and Micronaut and some other technologies. Ktor, I think, is getting better support for some of this as well recently. But Quarkus, I think, takes this to the next level, and that's why I wanted to highlight Quarkus here. So I've got my server up and running. Let's go give it a try. Localhost 8080. And what this app just did is it went out to the tags on GitHub for the Kotlin repo and fetched the tags and then returned them. And so it all worked. The app worked and loaded. But let's go now and make a change to my application. So first, let's go change the repo that we're going to access here to be my Kotlin repo. And I'm just going to save this file and come back to the browser and hit reload here. And you'll see this is taking a few seconds because it's recompiling my Kotlin code and then restarting the server. But now you see that change is now automatically there. You'll see that I have no Kotlin releases. As you'd expect, I've never done a Kotlin release, and you should not go looking on my GitHub for Kotlin, obviously. But trivial change there, but just to show that dev cycle was fast. So there's some other cool stuff that we can do that I'm not going to show live, but we'll tell you about with Quarkus that I think is really nice. One is you can go in the Quarkus console and tell it to automatically run your tests, or you can tell it to automatically run your failed tests. And so in the same action of saving my source code, I'm able to get my server to restart and have my tests automatically rerun as well. And so that's something that I end up doing a lot because it gives me just a super tight feedback cycle that is covering a lot of cases all at once. And you can optionally turn that on or off depending on what you're working on. Maybe you're working on something that you're testing, maybe you're working on a UI you don't have a test for, so you can turn it on and off. So that's one of the cool things that Quarkus is doing. Another thing that they're doing is they have support for test containers, which I'm going to talk about next. But the built-in support for test containers is really amazing in Quarkus. They've done a really good job with it, and I'm going to tell you about test containers next. Okay, so that is something that I just love to see in the world of Kotlin, is making that inner developer loop as fast as it can possibly be and across lots of different technologies. So I love that, and now let's go on to the next Slido, where I want to hear, for those of you that I guess probably most of you are developers. Are you building server-side Kotlin or not? I think this morning it was, I think Hadi asked, and it was about 30% Android or 30% non-server side, 70%. So we'll see if it's changed through the day. So server side, yes, we're about 65%, 35% no. Yeah, about the same split as this morning. Maybe some mobile people slept in and are now here with us. Thank you for joining me. Great. Okay, then one more question here is if you are a server-side developer, what framework or library are you using? So Spring is usually the most dominant with, that's great to see KTOR is doing well. Quarkus and Micronaut, other great options. All three now, Spring, Quarkus, and Micronaut, the traditionally kind of Java frameworks, all have pretty great support for Kotlin. So, that's been a wonderful thing to see. And I use all of them. I use all the frameworks and have kind of different reasons for picking different ones. But yeah, it's cool. A lot of Spring. Awesome. Okay, moving on to, we talked about server-side stuff. Now let's talk about test containers. So test containers aren't a Kotlin-specific technology. You can use it in not just JVM, but in all sorts of ways. So because they're not Kotlin-specific, I have a really good reason to include it, which is if you're doing Kotlin stuff that requires services, you have some service that you're depending on, whether it's a database or Kafka or whatever, some external service, some caching service, Redis, whatever. It becomes really challenging to manage that service in a way that makes your developer workflow productive and makes consistency between local development, CI, and production. Back long ago in the world of Java, the way that I would do things is I would use an embedded database called H2. Anybody here used H2? Oh, wow. Yeah, okay. You all know this pain. So I would use H2. And I would use it because it started up quickly, ran in memory, and I would write my code and do my local tests against H2. And then I would push my code to CI for CI to be built and tested. And in CI, it's testing against not H2 usually, but against the real production database, Postgres or Oracle or whatever. And all of a sudden, things would break. Things that worked locally didn't work in the CI environment, and maybe if I got really unlucky, didn't work in production. So what Test Containers does is it uses Docker containers to allow us to have the same environment, same service dependencies across development, CI, and production, which to me alleviates a whole class of bugs that I would typically run into. So I love test containers. It gives you the control over when the containers start, how long they run for. You can configure it to run however you want. So maybe you have a block of tests that all want to reuse the same container. Maybe you want to run each test in its own container instance and be able to run those tests in parallel. These are use cases that are very easy with test containers. If you're familiar with Docker Compose, this in some ways is an alternative to Docker Compose, except for with Docker Compose, the workflow for managing the lifecycle of the container is different from the way that you write your code and want to manage resources on the code side. They're two disconnected things. So I love test containers, and I want to give you just a quick little demo of using test containers. So to set this up, I have a sample application called Kotlin bars. You'll notice that I'm not very creative, and so I use like foo and bar a lot. And so this is an application that stores bars in the database, like foo bars, and that's all that it does. It stores bars, and so totally boring. And so one of the purposes of this little sample application was actually to explore Kotlin Multi-Platform, which we'll talk about in a little bit, and be able to share code across lots of different platforms. But I have a Spring server, and that Spring server depends on Postgres because I've got my database. And so I want to show you the setup for that I use with Spring Boot and with the Postgres test container and how I spin that up. So in my build file here, we'll see that I have a dependency on the Postgres test container. And that now brings in the capability so that I can start up a Postgres Docker container. Now I need to actually have some way to start up that container. And there's a couple different ways you can do this. There is a little bit easier of a way that you can use, which I'm not using here and I don't remember why. But in this case, what I'm doing is I have a Spring component that is a PostgreSQL container, and I specify the version of Postgres, and then I can init my schema with an init SQL, which you probably wouldn't do in something real, but was easy for this use case. And then I've got a configuration bean, which is going to set up my connection to that test container, and it's going to take the information that test containers has about the host and the port. It's randomizing ports, and so we can run many of these at the same time. And so it's taking that information and mapping it into my connection factory. Okay, so now I have the ability to start up my Postgres container, and what happens is I don't need to do anything else special. This is my test in this case. I also use that in the case of my main application. So I've got my web application that's using this bar repo to go fetch the bars out of the database. And the main application doesn't have any knowledge of it. It just gets a connection factory from that test connection factory bean and configuration there. Okay, so let's go actually try it so you can see how this works. I'm going to run Gradle and then server boot run. And when I run boot run, so I'm starting up my application. I also could have done the tests and ran the tests and we would see something similar. But you'll see right here, it's actually test containers is starting up that Postgres database and as part of that startup process. And now I can go make some REST requests to my server. So I've got my Scratch HTTP here. Let's go make a post request. So not found 404. That shouldn't have been to 404. I don't know why I was. Actually, probably I'm returning unit or something. So I think that maybe is 404. But anyways, I think my bar got stored in the database. Let's go now and do my GET request. And oh no, it's not working. Well, it's a demo. Sometimes demos fail, not sure why. Did I remember to shut down my Quarkus server? Oh, I did remember to shut down my Quarkus server. That's the problem. I'm talking to Quarkus. Let's close that thing. And let's go. My server shouldn't have even started, not being able to listen on port 8080. Let's try this one more time and see if we can make it work. Okay, so test containers, it automatically started up my database for me, mapped the configuration for that database into my application, and hopefully now let's go try it again. And fingers crossed, I should not get a 404 when I do my post this time. Yay, response body is empty, no content. No content is the right response. That means that yes, your bar saved correctly in the database. Now let's go do my get for my bars, and we see that sure enough, my bar now has an ID and is stored in my database. So, okay, so that works, and that's all cool. The database was spun up. I could run the test, same kind of thing. If you don't have a local Docker daemon that you can use, there's actually a new startup around test containers called Atomic Jar, and they provide the Docker service essentially in the cloud. And so you can use a cloud service instead of a local Docker daemon. So I just love test containers. It helps me not run into a whole class of bugs because my environment is different across dev, CI, and production. But there's something else cool that we can do with this that I want to show you. So in this sample project, I have a CLI application that my CLI, what it's going to do is it's going to connect to a host and be able to, have a CLI to create bars and view them. And what I have done in my project here is, if we scroll down, we can see that I have a new Gradle task down here called dev. And my dev task, because this is all in one project, my dev task now depends on my server building a container. So boot build image will create my Docker container for my server. And then what I do, if we can go take a look in here, I think is where it is that I can go and actually start up now, let's check out our server container. I can go start up the container for my server and the Postgres, wire those two things together, and pass the connection information from my server that was just started to the CLI so that it knows where to connect to. So now I've kind of taken my server container and my database container and made them dependencies of doing dev on my CLI, because maybe sometimes I'd want to be working on the CLI and the server both at the same time. But if I've got an engineer that's just working on the CLI, they don't want to have to go manually start up the server to run their tests, to do their local development. And I'm just using a CLI as an example here, but I've made this work for any client could take the same approach. So let's go try to now, I'm going to cancel my server. Let's go run the CLI. So that's the CLI dev task. And so now this is going to take a minute the first time, and there's probably some good caching that we could do. One of the cool things about Quarkus was that it keeps the test containers around across restarts, and we could probably come up with a way to implement that there in this project. Or Test Containers also has an option to keep the container running across restarts as well. So some different ways if you want to keep the container running. Also, I'm not doing any caching, so it's going to just recreate that server container every time I run this, which is not ideal. But okay, so it's going off. It's running the Spring, my server boot build image, which is using build packs to create the Docker container image for my Spring Boot server. And while this is going to take a minute to run, but while it's running, I'll talk a little bit about build packs, because build packs, they're not on my list of top 5 things, but also pretty awesome. So build packs are a technology that was initially created by Heroku, and then Pivotal also came in and created build packs. And what the build packs do is they take source code and they know how to turn it into a container image. So into a Docker container image. So what often happens in the case of Dockerizing, Docker containerizing applications is you have a Docker file, and that Docker file has a lot of knowledge in it. It has knowledge about how what the base image is, has knowledge about any security things that need to be put in there, any JVM flags and optimizations that need to be included. And so one of the great things about build packs is that they will take all that knowledge and standardize it into a build pack that knows how to take, let's say, a Java application or a Kotlin application or a Python application or a Go application, whatever, and be able to turn that into the container image. And the developer doesn't have to do anything. All I had to run was the server boot build image, and build packs knew how to take my Spring Kotlin application and turn it into the container image. Okay, great. So now my server Docker container was created, and it started up the Postgres container, started up the server container, and now I've got my beautiful CLI where I can come in and add a bar into my database, and we see, yay, there's my bars. So very exciting. My creativity is just flowing here with storing bars in a database. But there we go. That's test containers. So I want to show you that because I love test containers, and they have definitely helped me to be a lot more productive in a lot of ways. Okay, so let's move on to the next Slido question here. So are you already using test containers? So a lot of people are, but I think there's also maybe people that it's new to them, and so I just wanted to see how many people are using them. Great, 60%, 62%. That's awesome. And for those of you using them, thumbs up. They like changing your life, like they've changed mine. Yeah, thumbs up from some people. Cool. Well, great. Glad to see that there's a lot of people already using them. Hopefully, others can begin using them too. Okay, so my third favorite feature for 2022 in Kotlin is now something more Kotlin specific. It's the incremental compiler in Kotlin. And so first, let's go back to Slido because I want to hear compiler performance is a massive problem, annoying, or good enough. And obviously the Kotlin compiler is the compiler that we're talking about here. Oh, good. Only annoying for the majority. That's good to hear. And massive problem for the unfortunate 13% of you. So unlucky 13% of you, compiler performance is a major problem. Maybe the ones with very large code bases, I'm guessing. And so I have some good news, is that the compiler is getting better. So if you now in Kotlin 1.7 turn on the use class snapshot equals true option, then you are going to see some improved performance with incremental compilation. And so we did some preliminary benchmarks, and you'll see that add public method is about the same, maybe a little bit slower, not sure why. But if we add public method after a build cache hit, we're getting over 50% faster. So over 50%, twice as fast with the performance of the taller bars are better. No, sorry, the shorter bars are better. Can't even read my own chart. So we want to be shorter, take less time. And so, so the new incremental compiler, a lot faster on that one, a bit faster on change method body, and a lot faster on add string resource. So there's a lot of areas where this will have a huge impact on us as developers in terms of being able to have those tighter iteration loops that I talked about a little bit ago. So definitely excited about the improvements coming in 1.7, Kotlin 1.7 with the incremental compiler performance. Okay, so since there are 35% Android developer, I'm guessing maybe most of those 35% are Android. I didn't ask specifically, but since there are some mobile developers here, I wanted to highlight the inner dev loop for Android is called Live Preview and was just announced last week at I/O. And so I wanted to give you a peek of that. So I'm going to hop over into Android Studio, and you'll see that I, in a very limited amount of resolution, have my Android application up and running. And now I can come in and start making some changes to it. And you'll see that that's pretty snappy, right? I can come in and add some stuff here, font size. Let's go to 26.sp. And let's go bigger than that, 48. Like, this is using that incremental compiler improvement to be able to very quickly recompile a part of the code and re-render it on the device or in the preview screen. And we can come in and, of course, add new elements, that sort of thing. So, so if you are doing mobile development, hopefully this becomes a huge productivity booster for you, really tightens that inner development loop with what you're doing. And this, of course, is based on Compose. So the next question I have for you, for mobile developers, are you using Compose? Yes or no? I'm guessing since you're at a Kotlin conference, probably, but maybe not everyone yet. Oh, wow, that's more people know than yes. All right, find me at beers because I want to hear why not and what we can do about that. So, yeah, good to know. All right. Because you only get that cool live thing with Compose. So there we go. Okay, so the next thing that I am personally excited about, I can't speak on behalf of Google with this one, but I'm personally excited about Kotlin Multi-Platform. For me, it's a dream. Like, I want to be able to share my code across multiple platforms, and so I'm excited about this. I built that little sample app that you saw, Kotlin bars, and had a pretty enjoyable experience, except for some challenges with Gradle, and some challenges with Swift. And with signing my iOS application and some other things. But overall, I was like, this is really cool, the amount of code sharing that I can have across platforms. But the piece that I actually wanted to show today isn't the mobile piece of Kotlin Multi-Platform, which there is lots of cool stuff there. I wanted to show something that I just discovered a couple weeks ago, which I thought was just awesome. And so let's actually hop into a quick little demo. So I have a Ktor-based application, and this Ktor application is using Kotlin native, so no JVM. I can show you the build, but it's not using the JVM plugin. It's using the Kotlin Multi-Platform plugin, and then I'm running on WSL on Windows, so I'm just targeting Linux here and creating a Linux binary. So that is my build target, and then of course I've got my dependencies on Ktor too. And now let's go take a look at my source code for this application. I've got this silly thing that I use for demos. Is I have the service where I can go and ask it for a random number between, I don't know, like 4 and 10 or some weird word range. And then I've got another service which gives me a random word. And so what I'm going to do, what I wanted to do with this application is show one of my other favorite things, but isn't in my top 5 today, is reactive. So the ability to be able to make a non-blocking request to a service and then take the response from that and do something else non-blocking is awesome if you can chain reactive things together. So what I'm actually, and the ability to parallelize as well. So what I'm doing in this application is I am getting a random number, and then I am making that many requests in parallel to the random word service to generate a sentence of gibberish. And I just love how concise this code is. Like, it's just awesome. I'm using the Ktor HTTP client. I'm getting my number. Of course, this is based on coroutines. And so now I can use my number. I can create a list, and this is going to make the request to my random word service and then assemble the response. And it looks just really nice, doesn't it? I love coroutines. So this is my Ktor application that I built with Kotlin Native, and I want to go and now build this thing. So let's go over here. I'm going to call link release executable. This is now going to use Kotlin Native to build that server, and let's make sure I'm not running any other servers. I don't think I am, but okay. So that's now built, and so now I should be able to go start my binary Linux executable here, my gibberish Ktor, and here's the amazing thing, is that thing just started in like milliseconds, started super fast. So if you're in an environment where you're doing auto-scaling, serverless, that sort of thing, I think that Ktor and Kotlin Native are going to become a great option for being able to reduce your startup times significantly, reduce your memory consumption. I think I looked, this uses like 11 megs of memory, and the default binary size is 4 megs. With UPX, I reduced it down to like 700K. So pretty amazing that I can use a awesome high-level language like Kotlin and be able to build native executables that yeah, they're native, they start instantly, and don't use much memory. And I didn't have to like write any terrible code that has to deal with borrow checking, and I don't like being a garbage collector personally. I like to have things do garbage collection for me, but hey, personal preference on that. So anyways, I love being able to use this like high-level language and get the performance of a native application, a lot of the benefits of a native application. So lots of great things. I did want to point out on this that a lot of this, the new stuff that's coming with Kotlin Multi-Platform is really enabled by this new memory model, which is currently experimental. And so I think that I'm not sure what the state of this will be this year, but a lot of people have been having pretty good success with the experimental memory model, and I'm sure is something that the JetBrains team would like to hear feedback on from you if you try this. The new memory model is for Kotlin Native, so anytime you're targeting native, whether that's iOS or native like I'm doing here with Linux or Windows or Mac executables, you can use the new memory model. Ktor 2.0 uses this as well, and it works well with the new native coroutines and 1.6.1 coroutines. So give it a try if you're doing KMP stuff, and let the team know how it's working. Okay, one last question I think on Slido. Let's go back here. And so I would like to hear, what are your plans for Kotlin Multi-Platform? So already using it, plan to use it, or not planning to use it in any way? So that's great. A lot of people not planning to use it. That's fine. I'm not sure what I'm going to use it for yet, other than fun little demos. But great to see that some people are already using it. 13%, back to lucky 13 on this one. So, okay, that is, thank you for answering that. Okay, that is all the Slido questions that I have for you. So you can turn that off, and that's it. Okay, that's all I had for going through on my top 5. I want to get to beer. I'm going to be around I would love to talk with you, hear about your experiences with Kotlin, hear about what Google can be doing better with Kotlin and all that kind of stuff. I did want to shill my podcast, Happy Path Programming, and that's wherever you get your podcasts. And we just did an episode 2 ago with Roman, the Kotlin language designer, which was super fun. So lots of fun conversations that we get to have on there. So that's my shill. All right, well, it is time to go celebrate this wonderful day that we've had together. I hope my talk was useful, and I hope you learned something. Thank you so much.